Alrighty, seventh graders. So today is day 2 of solving and checking two-step equations with rational coefficients. Remember, your coefficients are numbers that are being multiplied with x, even if it is looking like division. This really is a 1/12. Okay? If you need to, check your answers from yesterday's homework. Okay, make sure you have your modeling showing and representing that you should have gotten all these answers. Okay? All right. So today's lesson is pretty easy. We're going to go through, we're in left page 38. We're going to do a few examples doing both modeling and the algebraic steps to it. Then you'll solve 2 problems to check your answers and then do your homework, which is only 6 problems. Okay, so let's look at example A first. Okay, example A is x divided by 2 plus 3 equals 7. Okay, so remember that means if you had half a circle, that's your half. X is the whole circle. And then we have 3 positives. And we have 7 positives on the right side. Remember, to cancel a positive, you have to do a negative. But whatever you do on the left side, you have to do the right side. So since I put 3 negatives on the left, I have to put 3 negatives on the right. That makes these cancel each other out. You can only cancel out with a negative and a positive. So that means this half of a circle is equal to a positive 4. But I want to know what's the whole circle. What's this whole circle? Well, if I have 4 and 4, that means then x equals 8. Okay? We took a half and made it into a whole because x is a whole circle. Well, how would we do this algebraically? Well, remember, we first have to undo our addition and subtraction to eliminate our constant. We have to get rid of that constant. Okay? So first, I'm going to get rid of our addition or subtraction using our inverse operation. So I have to subtract 3 on both sides. That leaves my x divided by 2 equals 4. Then we must always undo multiplication or division using the inverse operation. Now, if we want, we can pretend that this is really like having a half x. How would I get rid of that half? I would multiply by its reciprocal. So there's really an invisible 1 with that x, right? And whatever you do to one side, you have to do to the other side. Then we must put our solution. Our solution needs to be a variable equal to a number. A lot of you are just putting numbers and circling them. That's not how you put your solution down. You have to put your variable, in this case is x, equals, and 4 times 2 is 8. Now, if you notice, what I got here is the same thing I got in my modeling. They should match each other. If one is wrong, then one of them, if they don't match, then one of your versions is wrong. Then don't forget, we must check our work. Okay, and checking your work is not just writing the equation and putting a check mark. You actually have to do the arithmetic. Okay, so plug in 8 for x. Now I have to take my 8 and divide it by 2, which is 4. you are not done checking until you get the same number equal to the same number. That is when you are finally done checking your work. All right. All right, let's look at example B. I have x divided by 4 minus 5 equals a negative 8. Now, if I was just to only worry about my negatives first and just worry about getting rid of this and this, I would first put 5 negatives on the left side and 8 negatives on the right side. Well, I want to get all of my numbers on one side. So I have to undo this negative 5 first. That makes our zeros. That's what we want. And since I put 5 on the left, I got to put 5 on the right. 1, 2, 3, 4, 5. Those cancel each other out. Those are our zeros. And this tells me what I have left over is 1/4 of x. So if I had a circle, that is telling me that this is worth -3. That's worth -3, and -3, and -3. So how much is the whole circle? X equals a -12. Okay. All right, let's go back to our arithmetic way, or our algebraic way. I first got to get rid of the -5 with adding 5. These cancel. Bring down your x divided by 4 equals, you owe me $8 and give me 5, you still owe me $3 more. Now you get rid of this division. The opposite of divided by 4, multiply by 4. These cancel. Now I have x equals -12. Now watch those negatives. Okay, a lot of students I've been seeing are making that little tiny mistake of forgetting that there's negatives. All right, checking my answer. Take -12 divided by 4, or subtract 5 from it to get a -8. So -12 divided by 4 is a -3. Remember, add your opposite. Same signs, add and keep. There we go. All right, we need to pause this and then catch up. We got 2 more to go. All right, example C. I have 5 x's this time. Well, now we're switching it up to the multiplication. 1, 2, 3, 4, 5. And I have a negative here, and then 9 positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now notice how this is different than the other ones. Did I have any x's in my negative in my drawing here? No, that represented the x itself. Okay. Now I have 5 because it's multiplication. How do I get rid of a negative? A positive. So now we have 5 x's, and each x needs to get a positive. And if you know your multiplication and division, you know 10 is separated into 5 pairs. So then we know x equals 2. Shows you where it's different than the other ways. All right, I need to add a 1 on both sides because that's the opposite of subtracting 1. 5x equals 10. Stops in multiplication, division. 10 divided by 5 is 2. Then check your work. Take 5 times 2 minus 1. So then 10 minus 1 and 9 equals 9. Remember, you're not done checking until you get the number equals the same number. Okay? All right, example C. I have a negative x divided by 3 plus a positive 1 equals a negative 1. Okay? If I was worried first just about the numbers, I could have a positive here and a negative here. Okay? Opposite of a negative, or a positive is a negative, and I got to add another negative. That's where we get that. Remember, whatever you do on the left side, you got to do on the right side. Now, if I had 3, and each of these have a negative outside, and inside I'm putting 2 negatives, this negative out here, I'm going to change those to be positives. Got to do the opposite of what there is. So then x equals 2, 4, 6. Okay. All right, let's do the algebraic work. The opposite of adding 1, subtracting. And these cancel. And if I was to write this as a negative 1/3 x, that's the same thing. There's that invisible 1 right there. Equals a negative 2. Okay? I would need to multiply by negative 3 to get both the negative and the 3 to go away. That means when you multiply this by negative 3. Then we get x equals 6. So let's check it. Let's see if we get the same answer as in our model. Okay? So we have a negative 6 divided by 3 plus 1 should equal a negative 1. Well, negative 6 divided by 3 is a negative 2. If I add 1, say I'm on the number line, there's my negative 2. I remember adding, you go to the right. So then I do know I have negative 1 equals a negative 1. If you need to pause this, catch up with it. Okay. All right, next page. Pause your video. Okay, I want you to try these two algebraically. See, it says no modeling. Show all algebra steps. You need to. What's the algebra steps? Get rid of your addition and subtraction, then multiplication and division, solution, and check your work. That is everything we should see when you do this. So pause your video, then come back to see if you got the same answers that I did. All right, welcome back. All right, so this is what I got. I got x equals a negative 30. I had to multiply both sides by negative 6. This one, I first got rid of my 25 by adding it to both sides. Then I multiplied by the reciprocal. Okay, so that meant I had to multiply by 7/4 instead. Once you cross reduce, you get x equals 35. Okay, so you have 6 more problems to do on your own. If you have any questions, please reach out to your teacher. Otherwise, have a fantastic day.